Hopefully things went okay yesterday with your video and worksheet. Today we're going to go on and do 7-6, and it's titled, What About Other Bases? So remember that the expectation here is that you're taking some notes in your notebook and following along in the video. You have one goal today, and it's to use the exponent rules for bases other than 10. So basically until this point we've only worked with the base 10. Today we're going to look at number bases, other number bases, and we're going to get into some variable bases. Obviously still not feeling well. I hope to be back on Monday. So for your warm-up today, it's true or false, comparing expressions with exponents. So is each statement true or false? Be prepared to explain your reasoning. So for number 1, we have 3 to the 5th is less than 4 to the 6th. And we would say that that is true. And that's true because the base and the exponent are both smaller. So 3 is smaller than 4, 5 is less than 6, so this is definitely less than 4 to the 6th. Number 2, we have negative 3 being squared, or we have 3 squared. Well, this is false because when you square a negative number, you get a positive. So this should actually be equal. Number 3, we have negative 3 cubed and 3 cubed. These are not equal. This is a little similar to the one above, but because it's a cubed power, this is the third power, when you cube a negative number, you actually get a negative number. Because negative 3 times negative 3 is positive 9. Positive 9 times another negative 3 would be back to negative 27. So this is false. Number 4, we have negative 5 squared. Notice the negative 5 in parentheses is greater than negative 5 squared, where the negative and the 5 are not together. So on the left-hand side, we know we're going to get a positive. When you square a negative number, you do get a positive. On the right-hand side, we actually get a negative. So this is a really important lesson right here. I'm going to star this one so that you're really paying attention to this. But basically, you're only squaring or taking a power using the exponent on whatever it's immediately attached to. So on the left side here, it's attached to the parentheses, which means whatever inside is being squared. Here, it's only attached to the 5. This is actually the same as saying, what's the opposite of 5 squared? Well, 5 squared is 25, and the opposite of that is negative 25. So this would be negative 25, and this one would be 25. So this is true. But really understand that when that negative is not inside a set of parentheses, that your answer ends up being negative. Compared to the left side on number 2 and the left side on number 3, where we get positive answers because we have the negative inside the parentheses. So first activity is what happens with 0 and negative exponents. So we have a table here that I want you to copy into your notebooks. So go ahead and pause the video, take a few moments to copy the table in, and then we'll go through it. So we're starting on the far left with 16 and 2 to the 4th. And we're working our way backwards. So it's going to be 2 to the 3rd, 2 squared, 2 to the 1st, 2 to the 0, 2 to the negative 1, negative 2, negative 3, and negative 4. So 2 to the 3rd power, that's 2 times 2 times 2, that's 8, 4, 2, 1, 1/2, 1/4, 1/8, 1/16. And this, you will see, follows a very similar pattern, or the same pattern that we worked on yesterday when we were dealing with negative exponents with base 10. So let's answer some questions about the table. So as we move toward the left, we can see that each number is being multiplied by 2. So what's the multiplier as we move towards the right? This is similar to yesterday. We're essentially dividing by 2. Remember that dividing by 2 is the same as multiplying by a half. So we're multiplying by 1/2 as we move toward the right. Using this pattern, how would we write 2 to the negative 6th as a fraction? Well, what I want to share with you is that 1 over 4 is the same as 1 over 2 squared, and 1 over 8 is the same as 1 over 2 to the third. 1/16 is the same as 1 over 2 to the fourth. So if we want to write 2 to the negative 6th as a fraction, we would say 1 over 2 to the 6th, which would then be 2 to the 6th power, which is 64, so 1 over 64. So how do we write 1 over 32 as a power of 2 with a single exponent? Well, 32 is the same as 2 to the 5th power, so this would be 1 over 2 to the 5th, which we would say is 2 to the negative 5th. What's the value of 2 to the 0 power? Well, we've learned before with base 10s that anything to the 0 power is going to be 1. So make sure you do have this table, again, have this table in your notes, and that you're answering these questions in your notes as well. You're welcome to pause the video if I go too fast. From the work we've done with negative exponents, how could we write 5 to the negative third as a fraction? Remember that a negative exponent is the same as saying 1 over that base with the positive exponent, so 1 over 5 to the third, and 5 to the third is 125, so 1 over 125. 3 to the negative fourth, again it's 1 over 3 to the fourth. 3 to the fourth power is 81, so 1 over 81. So exponent rules with bases other than 10 is our next activity. Lynn, Noah, Diego, and Elena decide to test each other's knowledge of exponents with bases other than 10. They each chose an expression to start with, and then came up with a new list of expressions, some of which are equivalent to the original, some of which are not. So what we're going to do is look at first Lynn and Noah, and then I have Diego and Elena on the next screen. We're going to talk about their expression lists the same as the original. So Lynn's original expression is 5 to the negative 9th. Remember, when we have a power raised to a power, we multiply. This one is true. Having a negative exponent is not the same as having the negative out in front, so this is not the same. When we divide, we are subtracting. Negative 6 minus 3 is negative 9, so this does give 5 to the negative 9th. That one works. Again, we're multiplying. 3 times negative 2 is negative 6, so this one does not work. When we divide, we subtract. 5 to the negative 4th over 5 to the negative 5th. We would do negative 4 minus negative 5. When you add the opposite, that actually becomes 5 to the 1st, so that does not work. And again, when you're multiplying the same base, we add the exponents. Negative 4 plus negative 5 is 5 to the negative 9th, so that one works. Noah's original expression is 3 to the 10th. So what I'd like you to do here is pause the video and try to determine which of these 7 expressions in his list match 3 to the 10th, and then see if you're correct. So for the first one, we add exponents. This would be 3 to the 7th. Multiplying exponents, this is 3 to the 10th. Here again we have 3 to the 10th. This would be 3 squared to the 5th power, so this one works. we have 1/3 to the negative 10th power. So remember how that works. That means that this needs to go underneath. And now we have a fraction divided by a fraction. Or we have 1 divided by a fraction, so that's the same as multiplying by excuse me, multiplying by the reciprocal, so we do get 3 to the 10th here. There are other ways to look at this as well that we'll get into in our next lesson as we're practicing. 3 to the 7th times 3 to the 3rd is 3 to the 10th. We add exponents, that one works. Here we are subtracting. 20 minus 10 is 10, so we get 3 to the 10th. Again, subtracting. 20 minus 2 is 18, so this one does not work. So there are 2 here that are not equivalent. For Diego, he has x to the 4th as his original expression. So 8 minus 4 is 4. This does give x to the 4th, so that one works. Here we have 4 x's being multiplied together, so that one works. The third one, we are subtracting. Negative 4 minus negative 8. Negative 4 plus 8 is 4, so this one would give x to the 4th. That works. Negative 4 minus 8 is negative 12. This one does not work. Multiplying exponents, 2 times 2, we get x to the 4th. This would just be 4x, so this one does not work. And this is x to the 1st times x to the 3rd. Remember, we add exponents. This is x to the 4th, so that does work. So for Elena, again, I'd like you to pause the video here, see if you can do this one, and see if you can write down the ones that match, the ones that are equivalent to 8 to the 0. So remember that anything to the 0 power is 1, so that works. That does not work. Three plus negative 3, this would be 8 to the 0, which would be 1. That works. 2 minus 2, again 8 to the 0. 10 to the 0 power is 1. This would work. And 11 to the 0 power is also 1, so that works. So there was just one there that didn't work. So for our synthesis, we saw before that 10 to the 3rd shows repeated multiplication, 10 times 10 times 10. 10 to the negative 3rd also shows repeated multiplication, 1/10 times 1/10 times 1/10. So the question is, how do 2 to the 3rd, 2 to the negative 3rd compare? Well, 2 to the 3rd would be multiplying by 2 3 times. 2 to the negative 3rd would be multiplying by 1/2 3 times. Similar here, how do 5 to the 3rd and 5 to the negative 3rd compare? Well, 5 to the 3rd is 5 times 5 times 5. 5 to the negative 3rd would be 1/5 times 1/5 times 1/5. So this was from the warm-up. This negative 3 to the 4th power, where the negative is inside the parentheses with 3, compared to negative 3 to the 4th, where the negative is not inside a parentheses. So you're reminded here to think about what base is being repeatedly multiplied. The base that's being multiplied here is negative 3. So that's negative 3 times negative 3 times negative 3 times negative 3. That would give you a positive 81. And if we compare that here, this is saying what's the opposite of 3 to the 4th. So that would be 3 times 3 times 3 times 3, but take the opposite of it. So that would be a negative 81. Do other exponent rules work the same way that they did for base 10? Give some examples with different bases. So all of the exponent rules will work with any base. Variables or other number bases besides 10. All of our rules will work. What about combining bases? For example, do you agree that 3 to the 5th times 4 to the 3rd equals 12 to the 8th? And so this is a rule that we get into when we practice next time, but You can only apply the rules when the bases are the same. So we have a base of 3 and a base of 4 here. We can't multiply the 3 times the 4. So this is not true. You can only combine bases when the number or the base is the same. So they either both have to be 3s or they both have to be 4s. We will work on the cool down when I return to school. Your homework is worksheet 7-6 that you will need to get from the substitute after you show your notes.